I'll start on time. That'll be good. All right. Welcome. Thank you for joining us. Joining me here today. I know that the day after the party can be kind of slim, but I really appreciate you joining me today. Not my first one doing it at the end of a Cisco Live, but always get the good diehards to show up here. Thank you very much. So today we'll be exploring the multiverse of infrastructure development. It'll be a vast journey across the realms of infrastructure development. I'm Paul Zimmerman. I manage developer advocacy for the DevNet team. So we'll right over there in the DevNet zone if you're curious about any developer stuff. But for now, we're going to start our journey. All right, before we jump on our journey, if you have any questions or if you want to contact or have any comments or anything after the conference, feel free to use WebEx. We're at Cisco U-1775 for this session. Oh, and one other thing, our colleague here is handing out some tickets for a raffle that will happen at the end of the session, giving away this Fire TV. So pretty cool stuff. All right, so here's our agenda. I'm not going to dwell on it too long because this journey is a lot to pack in a half hour. But basically, this is where we're going. All right, so let's let the journey begin. So what am I talking about with the infrastructure development multiverse? So in the movies and comic books, the multiverse is when you have multiple realities that exist at the same time. In the infrastructure development multiverse, developers can set up applications across different frameworks and support massive scaling and flexibility using cloud services, and also efficiently and repeatedly run processes using infrastructure as code and automation. So this journey is a fantastic journey into the future of technology, a reality where disparate systems and frameworks can coexist and work together simultaneously. And we have the infinite scalability of cloud services and the efficient and unified umbrella of DevOps processes to get us going through this journey. So let's go. All right, we're going to start with our developer. Our developer, Dan, is working away on a task to deploy an application in a different operating system. Well, his application is working fine on his laptop, but when he tries to move it into the production system, it fails. So he wants to explore a concept that he had heard of but hadn't really gotten into, which is containerization. So what is a container? A container is a unit of software where it contains application, operating systems, has lots of different, and it's all contained within its own package. And those packages are maintained by a hypervisor, and that can go on top of any infrastructure. So these containers are lightweight, they're standalone and executable packages of software, and again, they contain the libraries and everything else you need to run the application. So Docker set the standards for modern containerization, and they found a universal way to package code and set it up so that they can be used across different systems. On the DevNet site, we have several Docker containers or Docker files that can be used for different products like IOX and UCS and others. Also, at the Docker Hub, there's some Cisco tags that you can search on, Cisco DevNet, Cisco Test Automation. And again, you can find more Docker files there to use with your systems and to play around with and edit. So our developer decided to give it a try. And he tried it on his system, it worked. And with the container, he moved it over to the other system that he was trying to do. And to his great joy, it worked without a problem. So he realized that containerization is a powerful tool. It greatly simplifies deployment, and it brought in a whole new dimension for the infrastructure development microverse. He knew that containerization would be a key to moving forward. So his next project, he was a developer that was very familiar with using the traditional monolithic style of programming. But his next project was a cloud native app, so he had to put his mind into a whole other realm. So in trying to learn about doing cloud native programming, he knew that he had to learn more about microservices, containers, and Kubernetes. Now, we talked about containers a little bit just a moment ago. Microservices are when you have a large application and you break it up into smaller bits, and so it runs more quickly and also more modularly. And also, Kubernetes is a system that is used to orchestrate containers and services and things like that. So putting all these things together, he was starting to get his head around what cloud native applications are all about. So in doing so, he found that he needed to see what was going on with his different services and applications. And to do that, he found that their observability tools are a key part of this whole effort. Cisco observability tools include Cisco's full stack observability portfolio. Developers can monitor their applications and check the dependencies and also optimize application resources. So having this visibility was super helpful. And then it happened. Suddenly, there was a spike in the traffic, and in the old monolithic model, this spike might have taken down the whole system. But because we were working in a cloud-native environment, it scaled up automatically to handle the spike, and then after the spike was done, the system scaled back down, and the flexibility of the cloud services definitely gave a good feel for what was needed to be done. So Dan also learned about Cisco's cloud native SD-WAN project, and this is where SD-WAN can integrate with cloud native technologies and work directly with Kubernetes. So it optimizes the application performance and also streamlines the workflows throughout the system. All right, so our developer stood back and was marveled at his effectiveness with cloud. It opened up a whole new approach to software development and changed his mind on what the paradigm was for developing software. He now found that he was not just a developer, but he was now a cloud native developer. All right. So while he's learning all these new skills with containers and cloud native development, he also found that manually configuring the networks was taking a long time. It was a lot of effort, and it was also prone to a lot of errors. So the next thing he started to think about was infrastructure as code. So infrastructure as code is when you have your infrastructure all managed within the software. You can write scripts to automate the creation and configuration of servers, and then eventually you get your entire infrastructure into code. So on the DevNet site, we have a bunch of materials to use for if you wanted to get your infrastructure as code going. We have Ansible collections, we have links to Terraform providers, and we have learning labs and sandboxes as well, so you can learn how to create infrastructure as code. Also, there's content about Cisco devices and how they interact as infrastructure as code as well. So as you can see, there's lots of products that support this concept, and it's all there, developer.cisco.com/AIC, and you can get your hands on some infrastructure as code samples and things like that. So infrastructure as code was great, but as our developer was learning more about this, he also learned about continuous integration and deployment, also called CI/CD. So this concept is where you continuously update your changes, you deploy them, and you test them, and it's all done in a continuous cycle and is done through automation. So basically, first of all, you start with your content management system or your version control system, Git. You connect it up with Jenkins to automatically build the code and run tests and all that. As you can see along the top, we have what CI/CD pipeline is all about, where it runs tests functionally This version is for NSO, which is Network Services Orchestrator. It can be done for many other products as well, but this is definitely one of the Cisco products that requires a CI/CD pipeline to make sure that the code stays consistent. All right. So our developer learned about infrastructure as code, CI/CD, and this was all a game changer for him. It helped him manage the infrastructure efficiently and ensure faster and more accurate deployments. So these tools really helped him prepare for the next stages of his journey. All right, so we're moving into our next chapter here. We began the journey as a curious developer, but now we can see that there's a sea of emerging trends that need to be addressed. First of all, there's edge computing. This is how you can bring computation and data storage closer to where things are being used. This helps improve response time and save bandwidth. So edge computing is certainly a concept that needs to be considered when you're trying to develop your cloud native applications, as well as any other infrastructure projects. Again, at Cisco DevNet, we have a lot of information about doing edge computing. We have things about the fog, where it's taking more cloud services and putting them closer to the edge, as well as more traditional edge functionality of putting bits of code closer to where things are being used. Again, with the edge, we have sandboxes that you can play with on the DevNet site, and code samples and learning labs. So you can learn how to develop for IOX and use code samples to help build your own code. Another key trend is security. Now, we all know that security is a big issue. We know that there are constantly new threats coming up. And the idea for developers is to shift left on security. And what shift left means is to put the idea and concepts of security at the beginning of the design phase and do it through design and development. So security is handled throughout the whole process. This makes the concept of security a key part of your whole software code rather than an afterthought at the end. So it definitely builds a more robust, secure system for you. Finally, sustainability is a big topic. We learn there can be you can have energy efficient data centers, e-waste management, and digital technology that all contributes to sustainability. Also, if you write script, you can write scripts to help with sustainability. For example, there was a session earlier in the week here about setting up Meraki ports so that they get shut down when they're not being used. So that helps save electricity. Also, there's certain software coding techniques that can save resources, like vectorization and asynchronous programming. You can use this in your code to help optimize your energy efficiency and resource usage. So there's lots of different things that people can do to make things more sustainable. And this is definitely a topic that many companies and people are interested in. All right. So as you can see, there's tons of stuff to do for developers, and working alone on this stuff can be very challenging. So even a superpowered developer can't do it all. So it's time for the developers to assemble. All right. So our hero has been used to working as a lone coder. He was used to owning his own code, working at his own pace, but he became part of a larger team working on a complex project and found that he needed to cooperate more with others. So the first thing that he had to do with his teammates was try to integrate their code together. Now, without a version control system, this can be really messy, can add a lot of errors in there. So the first thing they needed to do was work together to get on a version control system. So they use Git to manage changes of the versions, and it also improved the efficiency and the ease of collaboration. The next step in the collaboration journey was the introduction of DevOps principles. So within DevOps, developers and people who work in operations work together in a continuous cycle. This is the DevOps ideas are a culture of shared responsibility, frequent communication, and collaboration between the developers and operations teams. So this is a concept that is definitely important, especially on larger and more complex projects. Now, there are also a bunch of tools that are involved with this, and the team found that working together with these tools really helped build their automation and their content pipelines. So they use things like Jenkins for doing their release operations, using things like Ansible and Kubernetes to put it all up on the cloud, using Splunk to monitor their operations. So tons of tools, tons of things to get used to using, but it all works together to create a very useful and unified system. All right, so the team started working together. They also did. They also used those concepts like pair programming and code reviews, and they found that these working together created better code quality. It gave everyone a more shared understanding of the code base, and then everyone working together certainly was a lot more efficient than working individually. So this was a win. However, there was a new threat looming on the horizon. All right, so our developer had heard of AI first through scary movies like The Matrix and 2001 and things, and The Terminator and things like that, and then he found that AI was being used more and more in software development. So our developer was a little concerned here. Didn't know much about AI. Would it make the right choices? How would it learn? What to do? Would it take his job? I mean, that's certainly a concern that a lot of people have. So his AI team decided to implement a tool to manage their increasingly complex system, and they wanted to bring AI into it. So our developer was a little concerned about this. He didn't have a lot of faith in it, and when he first started using it, it wasn't giving him the right answers. It took a long time to train it to learn stuff, so he was a little concerned about it all. But he stuck with it. He hung in, and he learned that AI is not just a tool. AI is just a tool. It's not going to take over everything. It's just something that people can use to make their code better. He saw how a LangChain plugin. This is John Capobianco's code that he put out. That he built a plugin that could be used with a large language model AI. You could put in your questions in regular text, and it was trained on these different routers and systems, and it could feed back the information that was needed. So found that doing this, it could start taking care of a lot of routine tasks. It could also predict potential system failures and build some optimizations as it was trained and learning more and more. So in the end, our developer learned that AI wasn't a magical solution to all the problems, but it was a tool that he could use to bring benefits to infrastructure development for sure. Yes, as long as you're aware of its limitations and you know how to use it, AI is not a threat, but it's a partner in handling your complexities. Oh wait, is that Debbie? It sure is. Debbie is our DevNet mascot. As you can see, we have Debbie stuff over there, so he's joining us as well. All right, so as a developer, as a team of developers, you need to learn stuff too. So that's another reason why we're here at Cisco U, to find out what kinds of things infrastructure developers can learn from all of this. All right, so our developer is recognized the importance of trainings and certifications to validate his skills and show his competency, and so he dove into what Cisco U has for folks here. There's tutorials, courses, podcast videos, and learning tracks. There's all sorts of stuff that can be used here. There's everything from basic introductory things that are done by both Cisco and some learning partners, but there's also more advanced topics as well. So this stuff's all here to make everyone programming heroes. Also, the DevNet certs. We have DevNet Associate, which is the basic one to get started with. It focuses on the network programmability automation, DevOps principles, and software development and design. So there's some basic stuff you learn there. As you go on your journey further, there's the DevNet Professional, and there's also some tracks along the DevNet Professional for DevOps and security, where you can really show your skills and learn more in depth about these topics. DevNet Expert, of course, is our superhero certification. There's a few people here that have earned it. I met one of them just the other day. It's a tough one though. But yes, once you get that, you are definitely the hero. There are also other industry certs. These are all helpful and useful to show that you have skills in things like Kubernetes, Terraform for internet or for infrastructure as code. Things like GitLab are good for showing CI/CD and how to do version control. And then, of course, all the stuff's running on Linux. So being a Red Hat certified engineer is always a solid thing to have. All right. So our hero Dan saw that certifications were not an end goal, but really a stepping stone in his progress as a developer. In addition to the certification and training, though, he also learned that he had to stay on top of technology trends. In order to survive here, you need to stay on top of things. And to keep your eye on trends, it's good to consider your own interests and your career goals. So keep your eye on those kinds of things. Stay on top of current projects and see where the industry is moving. And then also work with your colleagues and mentors to find out what they know. And online communities are also a great way to stay in touch with what's going on in the world of technology and infrastructure development. All right, so there was our experience of the multiverse, but there's what's in store for our hero in the future. All right, so our hero had a great experience within how we are doing in the multiverse today, but the multiverse continues to evolve, and so does the journey of the developer. In many ways, the future is now, but there's lots of growth topics happening. Quantum computing is starting to make a splash. AI and machine learning, while we talked about AI a little bit, it's going to continue to grow, and who knows where it's going to go, so we need to keep our eye on that for sure. Security is constantly evolving. There's always new threats and people who are trying to get into your systems, and so they need to stay on top of that. To help support that, continuous learning and adaptability is a key concept to keep idea for the future. And then as we move through these advanced technologies, they're all going to become more integrated together. So by learning what you can learn and keeping your eye on different things, you can see how these things are going to come together in the end. All right. So as our developer journeyed into the future, his core approach remained the same. This was to be adaptable, to have a commitment to continuous learning, and also balance your ideas between new technologies and understanding the limits and implications of those technologies. So his journey through the multiverse doesn't come to an end. It's just challenging, continuing to challenge and learn about new things that are happening. And it's an ongoing story of growth, innovation, and exploration. And with that, Cisco U, again, has a bunch of stuff here that you can use to learn about infrastructure development. There's a QR code here. Of course, the folks here are certainly willing to help as well. I'd love to get your feedback on the surveys. And before we call it a day, we have a giveaway here. All right. Not licking. Not that I know who has what ticket is anyway, but here we go. All right. Ticket ending in 287. 346287. All right. We have a winner. Fire TV. Enjoy. Thank you. All right, everyone. I think that's it for continue your education here at Cisco Live. I'm sure you are doing so. I know that's the last day, so there's not that much more to do, but you're sticking with it. So keep going. And thank you, everyone, for joining. Thank you. No, that's the only one I have, but maybe there's more for.